Hello, welcome to the Optio Drive Assistant tutorial series by Infranor. This tutorial assumes you have viewed the previous tutorials in the series. Today we will continue the wizard walkthrough tutorial and cover the following topics: setting up the controller, position scaling, following errors, and profile modes configuration pages. At the end of this video you will have completed the minimum requirements for servo motor and drive setup and will be able to create motion in the system. Let's begin by starting with the setup of the controller. This page contains the settings for tuning the system by using auto-tuning and manual tuning. Additionally, you can find more information on this tuning process by clicking the question mark in the upper right corner. First, in the auto-tuning tab, the drive operating mode is selected according to the application. In our case, we are going to choose profile position mode as this is one of the most common operation modes, and tunes the system's gains for both speed and position. We are going to select position profile mode as the operating mode, then set the position loop requirements to minimum following error. We chose this setting over minimum position overshoot as it allows for the system to command the position more aggressively versus minimum position overshoot, which will more passively approach the commanded position to avoid overshoot. Next, we are going to set our filter type to standard. In the majority of cases this will work just fine, but we do have the option to set this filter type to maximum stiffness or anti-resonance depending on our inertia or elasticity in the system. Next, we are going to keep our sampling rate at 2 kHz and set our bandwidth to medium. These settings can be changed if we need faster response or if we hear noise in the system. Finally, we are going to set our speed measurement to auto as this will suffice for the majority of applications. Auto selects the best feedback sample time to meet tuning requirements. Now, click Start Auto-Tuning to start the auto-tuning process. This should get you close to the desired tuning of your system, but if this is not sufficient, we can also use manual tuning to fine-tune the system. Here in the Manual Tuning tab we can tune the controller manually by inputting values for low-pass filters, and by adjusting the gains in our position and speed control loops. This is a more advanced approach to tuning, so for the majority of applications you will not need to use this tab. For more information you can click the question mark in the upper right corner. If you are not able to use auto-tuning because the drive is in sensorless mode, then you can estimate proper gains with the theoretical auto-tuning tab. This window allows us to tune our system by inputting the motor torque constant, the motor inertia, and the load inertia reflected to the motor shaft. This concludes the setup of the controller. We are now going to click the arrow at the bottom right of the screen to proceed to the user position scaling settings. Here we can adjust how we want our position unit to be displayed, as well as adjust how position changes in the motor translate to position changes in the load. For our case, we are going to leave these units in terms of increments and set our display factor to 1. This allows us to use the feedback quadrature increments as position units. Next, for position scaling we are going to set this according to the quadrature counts of our encoder feedback, which was previously set in the motor configuration. For resolver feedback, you can use 4096 as default. You can click on the question mark in the upper right for more details. Let's click the arrow in the bottom right corner to proceed to the following errors modes page. On this page we can determine the error threshold on the speed and position control loops. We are going to leave this page as is, but we do have the option to set our position error detection mode to absolute or relative to a dynamic model. When relative to a dynamic model is selected, the actual error is compared to the theoretical error to given dynamic error, and that error value is compared to the threshold value to determine a fault condition. On the other hand, when absolute error is selected, the position error looks at the actual error and compares it directly to the threshold value to determine a fault condition. Let's click the arrow at the bottom right to proceed to the profiles mode settings. This page allows us to adjust the parameters for velocity, position, and homing profile modes. Next, we have the Profile Velocity tab. This allows the drive to control speed by using a velocity reference. In this mode, only the speed and current loop are closed. In the Profile Velocity tab, we can adjust the values for maximum velocity, the velocity window, velocity threshold and its time, acceleration and deceleration. We are going to keep these settings as they are set. In the Position Profile Modes tab, we have similar settings to the Velocity Profile tab, but instead of Velocity Window we have Position Window and Motion Profile Type. The Motion Profile Type has two options. First is trapezoidal, which allows a more aggressive motion profile, and second we have the S-curve, which allows for a smoother motion profile. Please note that the S-curve profile requires a higher peak current. We are going to keep these settings as they are set. Lastly, we have the Homing tab. This is useful when the sensor feedback does not give an absolute position. Here is a list of methods you can choose from while the drive is in homing mode. Homing mode allows us to change the method of how our motion control system determines its location. You can also change speed and offset of the homing moves while in this mode. We are going to keep these settings as they are set, then click the check in the bottom right corner of the screen to finish the wizard walkthrough. The motor is now completely set up. You are now ready for future videos. Thanks for watching. You can find additional information about our products and capabilities on our website infranorusa.com.